In today's in today's video, we'll be looking at how do we determine the size of our rectangular base prism. All right. So in the previous video, we looked at how did we get the development given the rectangular base prism, a prism that has a rectangular base prism. What would the development look like, right? And this is what we got. So in today's video, we want to find out how do we know the size, the measurement for our prism. All right. Now, suppose that we're gonna make a shoe box. All right, we wanna put a shoe inside the box, right? How would you get the size for the box if you have a shoe, right? How would you know the size, right? So, as you can imagine, the shoe would have to be, your shoe wouldn't be flat in the box. It would be vertical in the box, right? So if I was to draw something looking like a shoe in here, I guess we can draw a shoe that a robot would wear. All right, let's just draw a robot shoe. All right, so we're gonna draw a robot shoe. So the robot shoe would look like this. There, there, and there. Right? So that's one robot shoe. Right? So I guess his foot would the part that he would put his foot through would be here, right? And I guess the shoelace will be right here. All right, so let me draw the shoelace. So the shoelace will be right there. Good. All right, so this is one robot shoe. I guess that's the left foot. I'm gonna draw the right foot now. All right. So, all right. So I'm gonna draw the right foot there, 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 and there. All right. And then there and there and right. So I'm gonna put in the shoelace. Shoelace is here, there, there. Right. So I have the left foot and the right foot, right? And the shoelace. So you want to be precise. So let us put in the lace. So the lace, the lace. So we want the lace. Right. Let's put in the lace on the left foot. Right. So the shoe would actually be standing vertically in the box. No, it wouldn't be impossible. If you were stuck in a warehouse, doesn't necessarily have to be flat. It could be vertical, right? And if you're in a display showcase, it wouldn't be impossible to put it vertical, display the product with the cover removed, it being vertical, right? So I hope you can imagine now, figure out now how you would size the box to fit the shoe, right? You would measure the shoe, right? And because you want it to fit freely in the box, you would add on a little space right around it, right? So that is how you would determine the size of your isometric projection or your development. If you're gonna make a shoe box, you would get the two shoe and you would put a little space between the two shoes. Yes, I guess you would put some paper um padding in there to prevent it from rubbing on each other because you want to have a new shoe with marks on it, right? So you would measure the length, which is this length for the shoe to know how high this is and this is, yes? And then now to get the width of the box, you would measure this, and then add the spaces between here, there, and there to give you this measurement. How wide is that measurement? Good, good. And then to get how tall it is, you would have to let me draw the other shoe for you know, which is the side view of the robot shoe. So I'm gonna go here. There's a robot shoe. I forgot to put on the heel on it. But maybe it's a robot shoe, so it doesn't have any heel on it, like more shoe, right? You would have to measure this height, right? This height to get you to know how wide this would be, which is this measurement. You see that? So this measurement would have to be this measurement plus a little bit extra because you wouldn't want the cover to sit to touch and rub on the top of the shoe when you're transporting it, that it would have some rub marks on it when it's being transported. All right, so again, the length, this measurement will determine how wide this is, which is this measurement, this, how wide that is. Good. When you add the space between the box. Yes. And we're recapping, you know. And then this measurement, this measurement will give us how wide this and this is, and this and this. Yes, while this part of the shoe, this part of the shoe, this part of the shoe, I hope you can see, this part of the shoe would tell us how wide this part of the shoe would tell us how wide this space is, right? I- Am I correct? Yes, man. Right? This edge is this edge, you know. I have it twice. I'm just recapping. I discussed it already with us recapping, right? So in today's video, we looked at how can we know the size of our isometric box, right? It says what you're fitting in there would determine what is the size of the box. All right, so that brings us to the end of today's video. I hope it was useful. Did you find it useful? I hope so. All right, in the next video, we'll be looking at the construction of a rectangle given the dimensions, right? So maybe you could get a rectangle given the area and you're required to draw the equivalent area of a triangle or vice versa. So see you in the next video. Bye.